for Santa Fe in Aapresid. Thank you very much. Good morning, everybody. Welcome. We are very far from home here, so we're lucky to have you. Today we will speak a bit about the leaf hopper, which is what worries us right now. So first we will have the people from Sima speaking about the national network, and then with Andrés we will talk about the work that we are carrying out in San Justo, measuring the population of leaf hoppers. Agustin, Pedro, whenever you're ready. Thank you, Navier. Thank you for coming all this way. My name is Agustin Rocha. I have Pedro Lafluf from the data science team of Sima. Sima is an Argentine platform, a company that facilitates the countryside data through a web platform, facilitating communication and synchronization of everything that's happening in different plots. This is what we've been doing for the last 10 years. And the idea today is to tell you about our experience in the leaf hopper project, the management and monitoring of this very important pest. We began 4 years ago with the first project in Brazil. Sima is an Argentine company that is expanding throughout Latin America, and that through our users and clients that we have in Brazil, we saw this dilemma that we were facing. Thank you. So this is how we began. The first part was what we called Esquadrão de Combate à Cigarrinha in Portuguese, which is a combat squadron for leaf hoppers. And it was basically deploying traps, sticky traps, and monitoring them and authorizing all producers in the region through commercial distributors to tell them what was happening in their particular areas. And when we began with this, the intensity rose and the importance of this pest rose. And in some areas in Brazil, they decided in some areas not to plant maize. And through these practices of monitoring, alerts, and management, we were able to at least be able to keep up production. This is how we began together with Bayer. And then we scaled up the project and we expanded to Colombia. And this year we are beginning in Argentina with a national monitoring network for this particular pest, with all of the institutions and the companies that accompany us. There is the number of traps that have been set up until now. In Brazil, it was over 10,000 traps throughout these 4 years. Just to give you an idea of where they were set up, you can see clearly here through the different sowing periods where the way this pest was monitored. And you can see the distribution that they had throughout Brazil and also the dimensions of the different projects. The 120 traps that we set up in Colombia with 457 registries and 10 users. And in Argentina, we have 240 traps set out and 80 users who are doing monitoring. Here we have some people who are doing that. How did it work, this squadron in Brazil? There was many people who were monitoring and reporting it through an app. And this went to a control panel where we could see the evolution. We could see where the areas of greatest growth or where the pest was really catching up. And we had different reports that were then distributed to each of the zones. And then these were distributed to each of the producers, making sure that they were alert and they could prevent. You can see here examples of these reports with heat maps and values and figures of how the pest was advancing in each of the municipalities and states. And this, Pedro will add to this information, but actually this took us to the development of a specific module for monitoring this pest, done with a Chilean company for traps, and the Cooperative of Agriculture of Brazil as well helped us with this. And now we have this monitoring of Dalbulus, this particular species, that we are also doing in the network in Argentina. Good morning, everyone. What we're seeing here is Sima's functionality. What we want is tell our users that there are certain adversities. These are alerts or notifications that we send our users that because we have detected in this case the leafhoppers. What we can see on the graph is the amount of plots that received an alert. That doesn't mean that the pest is there, but the fact that near them we can detect that adversity via our own users. We can see those alerts. We can see a rise in the alerts between January and February. Before we didn't have any reports, and this was the first indicator we had of saying we have a problem here. What Agus was saying with regards to the specific module that we have just launched, this module registers the amount of individuals per trap. Each trap is geolocated. You can adjudicate a radius of, I can say, the coverage of so many kilometers that it can cover per trap, and we can determine what coverage we have in each area. The other thing that's very important is the report of ineffectiveness. Out of those traps, how many can transmit spiroplasm, which is what is creating an impact when it comes to yield. As I was saying, this is a real picture of the new module. You can have a georeference, you can have a radius of influence. You can see that the traps are monitored, and down at the bottom, the amount of individuals that that trap has. There is a new module. This is on the web, where we have developed some control dashboards and these maps that tell us where the traps are, and according to the number of individuals is the color. Some indicators that we have that come out of the work we have been carrying out with Brazil. This is the amount of the average number of individuals per trap per week, and you can filter this information by area, so you can see how the pest is doing in each area. What we're seeing here is weekly the positivity of traps, how many traps have this particular pest, and that indicates the distribution, where we can see it, whether it's rising or whether it is reducing. This is what we have been thinking about in future. This is our plan. We have a co-development together with a Chilean company and with the cooperative from Brazil, as I was mentioned, where we have these automatic counting traps. They have the advantage of not needing somebody to actually go to the plot, because unless, of course, if it's not sending a signal, you'll have to go and check it. But otherwise, it has automatic counting of the individuals that it can have within it. There is a pilot test that we will do throughout 2024 with 90 traps. Some of them will be in Brazil and others will be here, right? They are very popular, so we will see how to distribute them because we don't have that many in the first series. And when it comes to Sima's own development, and when it has to be with regards to our team for data science, we're trying to get the automatic counting that the trap has can be included within the app. We are doing some testing so that you can count through the phone, through your cell phone, quicker. And the other thing we're doing is trying to do not a model that is not so much predictive, but the actual evolution of the population of these insects in future. That's what we are working on right now. Here we wanted to show you a bit what we learned in 2023 and 2024 and what our users have told us. What we can see there is the distribution map for monitoring that showed the presence of these insects. The hotspots here don't talk about really the quantity of individuals, but actually the monitoring and the presence. What we're seeing there is a permanent evolution from January to April. When we began to analyze this data, this actually began in October, but we first detected them in January in Argentina. And this is why these images, we did away with the January monitoring, and we can see the dispersion and the rapid progression of this pest. And here we began to see the context and understand why you could see that particular hotspot on its own, which can be a bit biased by our own users. But we began to look out in the region, and we saw that the first detection in the region was in Brazil during the first few days of December. And although it seems that it's far away, there's only 500 kilometers between these two spots. And this morning, I started searching for information about the winds during December and January in that area. And the truth is that the winds show that there was a lot of southeasterly winds. So this is a hypothesis, of course, but I think this pest is conditioned a lot by the region more than locally. This is what we learned also in 2023 and 2024, the distribution of spiroplasm and leafhoppers. And what we can see is the phenology of the crops and the peaks of detection. You can see and detect the presence of these insects at the first part of the crop with high distribution, and then we see a second peak that has to do more with the disease than with the insect itself. We can see a lot of more spiroplasm and not so much phenology. Something to think about, this is monitoring of plots, not traps. We're monitoring the crops themselves of people who are actually going through the plots and can detect either spiroplasm or the insects themselves. So what we can see here is the plots and where they are distributed in Argentina, and we also saw that they were very much concentrated in the north of Buenos Aires and the south of Santa Fe. And when we clicked on them, we realized there was a lot more late maize than up north. And that's why the distribution of spiroplasma happened in that area. Finally, what we're seeing here, these are data that are public now, and this is the national network that we mentioned before, where you can see the distribution of the monitorings and the traps. Those are the blue dots. And what you can see in the heat map is population, where we can detect most of these individuals per trap. I think they have monitored, this is information from the last month, and these are some points that I think are important. The date for the last cold snap in the north, I think this was an alert. When it comes to the center, there's not that much risk, I don't think. But today, we can see some problems, but we still see the presence of these individuals. And finally, the capacity for infection that they have, how many of the leafhoppers can actually transmit spiroplasma, as we mentioned before. And finally, once again, these are the maps that I put up with Brazil. This is April 22 and 23. It's actually April 24 and April 23. Sorry for the correction. I go back to this. This is not a conclusion. I don't want to say that this is the way it is. I'm just giving an alert saying that we should work on a regional basis. We should work Argentina, Brazil, Uruguay, and Paraguay together, because I am Uruguayan, and we had a big problem with one of these pests, and that's what I think. You have to work on these diseases regionally. What the neighbor does impacts me, and when it comes to these kind of crop diseases, we have to think as neighbors, because in Uruguay we had a big problem with foot and mouth disease, for example. So that's what I'm worried about. Thank you.
A ambos. Bueno, ahora vamos a pasar a nuestra presentación.
Thank you both. And now we will have our presentation. We will be sharing this presentation with Andrés. What we are doing is our final project. Andrés needed a project to graduate, so this is a university project. Good morning, and I would like to thank the San Justo Cooperative. They sponsored us to carry out monitoring, and let me share with you our roadmap. This is how the project was born. We thought about the impact of the leafhopper this year. We studied to see the need to monitor behavior during the winter and to check the situation in San Justo area. We tried to determine the behavior where they seek refuge. For instance, they go to the forested areas. And then we are going to talk about the traps, the methodology, the quantity per lot, the location. Then we are going to talk about the results, and we will have some conclusions. The idea is to measure the dynamics of Dalbulus of leafhopper for a first harvest of maize. This is the scope of the project. You can see the location with the pins and the distribution of the samples based on the different departments in the province. Each pin represents one lot with 4 traps. There are 20 traps in total, and the center is San Justo and the surroundings. So these are the different districts or departments where the lots are located. Why did we choose San Justo and why in the winter? The question is what the season was like. San Justo during the summer was really very warm, very hot. So we could predict what the winter would be like and the season timing. So why San Justo? Going backwards, perhaps in retrospect, it is easier to understand what happened. This is the rainfall level for 2023. In June, July, August, September, there was no rainfall at all. I was telling you that normally planting occurs during August and September, and there is also some planting activity in January and February. Here you can see that in October there was rain, 48 millimeters. So sowing started, and it was a continuous process. All weeks there was planting of maize. The vector had fresh food from October onwards. In the 2024 season, you can also see the months on the screen with planting from August onwards until February. This is a heat map developed by the Cereals Exchange. And here you can see the evolution of the impacted area. This is not just the spiroplasma, it is also all the other stages of the leaf hopper. The hot area in January is in the center and north of Santa Fe and also in Entre Rios province. You can see the evolution in February, March, and April. In the center of the country, we had a focus of impact. I have 1 million photos, but this is a photo from San Justo. With the magnifying glass, you will see the test we did. We had to count the number of insects per plant, and with this first counting, we had like 40 or 50 insects per plant. The dynamic is very complex. It's difficult to count them because some of them are flying. There was no more space in the plant for the nymphas. So you can see that they affected the lower leaves. This is a photo of a plant that is overtaken by the insect. There were leafhoppers in any stage of development, so the plant was deeply affected. And all those lots, you can see the photo. The spikes that were more or less good, they also had problems. And this is an SR that we had with the regional unit. When we were telling them that it was complete chaos, they wouldn't believe us. So the entire lot was ruined. And the humidity was 22%, and the production was from 1 to 5 quintiles. We were trying to predict what would happen during winter and where they would seek to take refuge. If we would have periods of wind or frost, and also the relationship between male and female. According to theory, the proportion of females is higher during the winter. So now you have some examples of monitoring. We had sticky traps. They are easy to set up on stakes, and the size, you generally have a sheet that is 20 by 25 centimeters. So it is good to divide this sheet and to have two separate parts. And it has a film that you have to withdraw. And here you can see the height where we set it up. We have different markings on the stakes to be able to bring it to higher measures. And as we will soon show you, this is where we can find the counts, also considering the center of the lots. There is a difference with the traps in the national network. The stickiness is already provided in the sheet. You don't have to add the sticky material, and the size varies, but it's the same concept. As Andrés was showing you, this is a representative lot. We had two traps at the start or head of the lot, and also in the center. There is a lake. We would not be able to do it inside the lake, but for the other lots, you will be able to see the positioning. Yes, we had to go around the lake because there are many insects. There are natural enemies of these insects that can also make a contribution. Something to note, when we went to check the first traps, the stickiness is very strong, so transportation was a problem. The adhesive. We found the problem that they were difficult to carry because they were so sticky, and we had to come up with some ideas so that they would not be stuck to other surfaces, or they would not be stuck to each other, disturbing the sample. Yes, this is a glue that sticks to everything, and they are able to withstand the wind. We also had a spreadsheet or a form for our field work. We were in the last season we had fewer specimens. It was easier to record. So we used this form. We also used a magnifying glass. First, we had a manual magnifying glass. Then we acquired an electronic magnifying glass to be able to observe in more detail. As I told you, the lake was a factor because we had other insects on this glue or sticky material. We had bees, We had other insects that can be predators of the leafhopper. There were also butterflies and many insects, as you can see. So one should take care and identify the leafhoppers carefully based on their physical characteristics. Some of them are white or whitish. Now, it is very important to note that there are many different insects that will be trapped. So we can identify them to avoid overestimating or underestimating the quantity of leafhoppers. And, well, this is based on experts' recommendations. These are some specimens, the difference between females and males. We always see the stains. Here you have the difference between the two sexes. The wings, the clear wings. So color is something to consider because during the winter they will be darker. So their behavior in the field, we have not had any rainfall. So there was an episode of frost and the activity is virtually zero under those conditions because they will freeze. But when temperature goes up, the stickiness works again. We do a weekly replacement of the traps in order to see the fluctuations in the dynamic. It's also important to consider the winds in the lot to position the traps correctly to avoid the traps from being damaged, and we also add some tape to secure them. And they are positioned considering the wind. With the tape, we reinforce the support. We selected different lots for placing them. In San Bernardo, we used Vicia on sorghum. In Angeloni, soy. In Videla, in Ramallon, we used maize. And in Videla, also maize. Oats in Cachastacito. So this is to give you the dimension of the lots, give you an idea of the dimension of the lots and the location of the traps. We took as reference Road 11. This is the Angeloni road. You will have to select the right traps or the right positioning for the traps based on the lot. You need to get to know the lot very well to understand what the best position can be, because there are differences. Now we will see the results. One of the questions is, where will this insect take refuge? We have seen that they go to forested areas or covered areas or to grasses. Will they stay in the stubble? Will they stay with the maize that has weeds? So we started asking these kind of questions. And these are the results. there have been 9 sample takings. These are weekly samples. And this is a chart that we get of the total adults per sample per lot. You can see there are 9 samples, and those are the dates: June the 5th, June the 13th, June the 20th, June the 27th, July the 4th, July the 11th, July the 18th, July the 25th, and August the 1st. You can see the freezing or the frost symbol on the left. You have probably heard others talk about how cold it has to get for a frost to occur. The idea is to understand whether these insects are dormant or are frozen or are paralyzed when it is too cold. So we started doing a survey in all of the lots. In most of the lots, we had 30 adults on June the 5th. The total adults, 133 for that sample. Now, you can see that for the second sample, there was a peak in some of the lots. We ended up having 209 leafhoppers trapped. In Angeloni, we had soybean stubble. So we started to wonder, are they staying in the soybean stubble? What are they doing there? So there was also an increase in 2 other fields or lots, one that was planted with visia and sorghum. Now, in the field with soybean stubble, you can see that there was a decrease, a remarkable decrease. There was no application. This was wild maize with weeds, and it remained at a very low level afterwards. In the third sample, the total number of adults captured lowered. It was 136. And Angeloni lot, the one that has soybean stubble, was the one with the highest number. All of the others dropped, but this one increased. Now, the biggest drop occurred in the week from June the 20th to June the 27th. It was not the period of the peak frost. The frostiness came afterwards. There was a drop in temperature, and we went from 12 total adults to 14. We had a slight increase, but then we went back to 2, 3, 2, and 1. There is no 0 level. These are the total captures. So you can see how the curve has evolved.
And in the other graph, you can see that from 20 to 27, it goes down. We have another jump down. And then in the last samplings, it's gone down. So we have managed to capture 500 adults.
Bien, yo tomo un muestreo acá para hacer.
This is the sampling I took to make some comments. From the 13th of June, this is the one where we had 209 adults captured. First, we're going to go to the map. The traps are very close to each other. They're not far. So, in the national network, the traps are 100 kilometers away to have an idea of a zone. Because if we have to put one every 15 kilometers. It wouldn't be logistically possible. But what we want to do is to sample the area in San Justo. So we decided so that it would be logistically possible to be 15 to 20 kilometers away. You can see in Callastacito, in Videla, it's 25, 30 for San Bernardo. Then Angeloni, Videla, 13. So it's between 15 to 30 kilometers. But look at the difference of adults captured on 13th June. And let's go to one. Look at the red in soybean stubble against Videla, which is maize stubble. And they're 13 kilometers away, one from the other. So they're very close. So one had maize and the other one had soy. So we began getting this data and we began asking ourselves why. Check Callastacito, which has always been the lowest. Here in Ramajon, Angeloni had second maize, and there was less than in Angeloni. So there was something there. They are always somewhere. These are the adults, Angeloni versus Videla, as I was just mentioning. Soybean and first-rate maize. You can see there's been more captures, always in Angeloni. Look at the second and look at the third. How it shoots up. There's a lot of difference in very few kilometers. You can see here the adults, the center of the plot, or the start of the lot. You can see the red bar and the blue bar. As always, the traps at the head of the threshold of the plot. You can see always that the pest goes in through there, except on June 20th, which is a bit similar, but then you always get more at the head of the plot than in the center of the lot. This is what we were saying about Angeloni. This is soybean stubble. Four traps that are 150 meters away. And this is 13 June. In Angeloni, we divided it on east and west. Look at the difference between the west and the east traps. Look at the difference. E1 and E4 is in the center, and this sampling is clearly shows that there's more at the center of the plot. You can see there were 4.5 times more on the west than on the east. So they were coming in through that area. You're probably going to say there's some stubble there. No, it was sorghum with Vicia. And this side there was soybean, and we did not have any maize nearby. We did not have a scrub nearby, nothing where you could say they are there. So they're somewhere, but we don't know where. And these are the total sampling, all of them together, the 9 of them. On the west, still more capture than in the east. In all of them, 149 against 46 in all of these samples. And check how E4 on the east side is different from E3, which is in the center of the lot. So they were coming in through one of the headers and then through the other. Do you understand the difference? This is the entry to the lot. This is all of the samplings in Angeloni. We just brought one plot because otherwise it would be too long. But look how on the west you always capture more than in the east. So they come in normally on one side, which is what the books show us. I am sure that you will say, what about temperature? What about whiteouts? These are the temperatures from the first week of sampling till the last. These are not the minimum temperatures, these are averages. See how the average goes down in temperature. It goes from 20 to 27th. It goes from 14 degrees to 11. Then we had more cold, more freeze, and then the temperature went up again. But the captures didn't go up. After the temperature went down from 14 to 11, they don't go up again. So after, when it goes below that temperature, the pest hid away, probably. And then we're going to see that. There were many days that were windy. More wind, less temperature, they don't go out and fly. It is hidden. All of these things beg the question. There is a correlation that needs to be analyzed further. This is the capacity for infection. Alejandro was in San Justo in February and took some of the leafhoppers to analyze. This is the capacity for infecting phytoplasma. This is just plasma. The percentage in February was 23.3%, and it is comparable to the 30% from Tucumán, which is the hot spot. And we were very similar to Tucumán. And the other highest percentage of infectiveness was very similar to Tucumán as well. This is really hell for us. It is the gates of hell, actually. And a bit about the relationship between the sexes there. We wanted to do effectiveness and the relation between this. Of course, it's difficult to analyze, and with the sticky traps, they can give you false positives because the DNA degrades and they die, etc. So what we try to do is to look at the bibliography, and what they say is that the females are bigger than the males, and they have more possibilities of surviving the winter if there's no maize. So we have 3 females per male, or even 4. The vector can survive about 9 hours at -5 degrees centigrade. So that didn't happen. We did not have 9 hours at -5 degrees. It doesn't happen in our area. That's why we can still find them. So it is logical to keep on finding them. And then they say that females who are migrant and hibernate are bigger, and they are darker in color. And adult insects can survive without feeding over 75 days when they have the temperatures between 9 and 17 degrees centigrade, and the infected individuals with spiroplasma, especially females, survive even longer. So in April, we ended up with, I'm not going to say a number, but it'll be higher than what we thought. They don't just have spiroplasma, or the infected females survive more, even if they're infected. And in the traps, we have found Dalbulus and other types of leafhoppers as well. I consulted yesterday. Some of them have macules, some are circadian, some are not maidis, but others. And this will always be something that we need to improve on, taxonomy and detail, and be careful when it comes to giving any type of prognosis, because we don't know whether they are infectious or not. What we have been seeing is these are the ones that we have found, and these are not Dalbulus, these leafhoppers. So be careful, because they're very easy to confuse. I either underestimate or overestimate. It's not so easy to see the trap and say these are all leafhoppers. They may be other things. Macarena Casuso said in alfalfa, look at what they have. Just the yellow is Dalbulus maidis. The others colors are others. You can see here at the bottom, especially, I don't know if you can see them properly, but they look very similar to Dalbulus. You might think it is the same. And they're not. It's a different species. So it's not so easy to identify. Sorry, we don't have a mic.
Ahí vamos, ahí terminamos y ya.
We'll go to questions in a minute. So we were missing the conclusions. When it comes to conclusions, we can see a high variability of captures in plots a few kilometers away from each other. The national network is fantastic, but if you're going to sow maize, please set up traps, because it could be dangerous. The national network won't work for that. There's high variability of captures within a same plot. If you had in Angeloni on the east, and you would say we're not doing well, we're doing well, there were less than on the west side. More captures at the beginning of the lot. The temperatures have had an impact on captures, but maybe the insect has just taken refuge and not fly. Or was there mortality? Are they just hiding away? And why do we say this? Because when we sort them out, we could find them. We wanted to find them, to collect them, and to analyze them. And we picked up leaves from the lot, and we found within Avicia, in San Bernardo, we found one that was hidden. We went to another plot, and we found them in a scrub, and in a maze, we found them as well. So the insect is there, but it's paralyzed. It's not flying around like it does in winter, in summer. So it is paralyzed because you turn around the leaf and it doesn't move. A while later, it tends to fly away. And to close, there is a presence of the vector, not just in the traps. You can find them if you look for them. And you need to set up traps. That is the final conclusion. I don't know, Andrés, if you want to say something. Yeah, it is important to generate the information to set up traps, because in many of the plots, many of the producers have seen what the methodology is. They're easy to set up. You just have to go through the lot. I've been coming to this Congress for 3-4 years. You have to monitor and go through the traps. It doesn't take long. You need to set up traps. That's the final conclusion. Thank you.
Perdón que se pasó un poco el tiempo. No sé cómo estamos, pero si hay preguntas, no hay problema.
If you have any questions, there's no problem. We can continue, but I don't know whether we have time. How do you differentiate the dead from the alive one? Is there another quick method to determine infectiousness so that producers can actually measure that winter in particular to see what the population is? No. The infectiousness, you can just do it by PCR. You have to send a pool of leafhoppers. You can send individual samples or a pool, and you measure it, the spiroplasma or phytoplasma. You can just do it on the lab. So the sample is on the plant. No, on the leafhopper. You have to get the actual insect. It has to be captured alive, because when you take it from the trap, it's so stuck that there may be a problem. Alejandro was telling us that if you want to take it out of the trap to check the infectiousness, it shouldn't be on the trap for over 12 hours. What they do is they go in the morning before the 12 hours to take them out, but the method may not work. It could be a false positive or false negative. And then to identify the winter, the taxonomy, to see if it's Dalbulus or not, you need a magnifying glass and a WhatsApp. Everybody has the number. You could just send pictures to our experts, or the idea is to keep generating information so that they are easier to identify and to see what will happen with Dalbulus. Yesterday they spoke about a different leafhopper as well, so it's all pretty much the same. So we go back to identifying them, because speaking with Ale, you can send them pictures and they may say, I don't know. And if they don't know, of course, we don't know either. Sorry, no mic.
Pregunto si la trampa.
The question is, does the automated trap detect everything? Well, it has been designed with human parameters, so it will carry over any human error. There is a percentage of error. It can be corrected, but it is a way to have faster measurement. So we have a compromise between the quality and the rapidity with which you can calculate or count. It is very hard to convince producers that the leafhopper can become a really serious problem. What do you think about that? Based on this data, what we see is that the insect did not disappear completely. When we have frosty seasons, and in April or May, we were talking about this, and they were saying, but it has to be really, really freezing with 3 meters high of snow for them to die, because there are so many, the quantity is so huge. Because I was counting 40, 50, 60 per plant, and only 50% is on the plant. When we measure, the rest of the insects are flying. So maybe they're hiding somewhere, they are not flying. I don't want to, this is by way of warning, just be careful. Thank you very much. Last question, because we don't have more time. When maize has been planted and it has grown, do you do monitoring on the crops, or do you also add the traps? I would always add the traps from the moment the sowing takes place. Doing it on a weekly basis is complex. It would be the ideal, but we see lots of variability from one week to the next. If you monitor the lot, you have possibilities to understand the numbers. So you have to do 2 actions. Go and check the plants and also install the traps. The people in Brazil, when they see 1 leafhopper, they decide to spray the lot to exterminate. And there is monitoring in Brazil. When they detect at the head of the lot, we need to control during the winter as well. This is complex, but use the traps, and if there are leafhoppers, if you detect them, take precautions. Thank you, Agustin, Javier.